Let's talk about duration-based costing, DBC as it's sometimes referred to for short. Okay? It's a before-the-fact simplification method that eliminates the need for stage one of ABC, activity-based costing, and it dramatically simplifies stage two. Okay? It's as simple as a traditional unit-based costing approach, but it has the same accuracy as a comprehensive ABC system that uses duration-based drivers. Now, you need certain information, 4 items of information. First, you need the cycle time for each product, right? And we're referring to the product here would be the cost driver. That's the first item, and you see that highlighted. 2, you need the practical capacity for each product or cost object. You need the total overhead cost, and you need the total time of all the primary activities. Now, the first 3 items are given to you to solve the problem. In other words, they're observable, and you would find them within the organization's cost accounting information system. Let's go over a few other concepts. Cycle time is the length of time required to produce 1 unit of product. So we're talking about calculating a time per unit cycle time. And every activity consumed by a product contributes to its cycle time. So the expected total time, in this case we're doing it in hours, spent with primary activities for a single product, which we'll refer to as product I, is the cycle time multiplied by the units of the product produced. So we have what you see on the screen here. T for I is equal to C for I times P for I, where T for I, or T sub I, is the product I's total time used for primary activities. C sub I is the cycle time for product I, and P sub I stands for units of products of I produced at practical capacity. So if you wanted to calculate the total time in the system for all primary activities, you would sum all of the product's total primary activities. Okay? Just take the sum of total time. All right, now moving along, we'll start focusing here where you see the mouse moving there, okay? So once the total time in hours is known, then a single predetermined overhead rate for DBC is computed as follows. The overhead rate would be equal to the total overhead cost divided by T. And using that rate, then you can assign the overhead cost to each product by taking the overhead rate times C sub I. And remember, C sub I is the cycle time for that product. Okay? So the total overhead would be the overhead rate times the C sub I times P sub I. What was P sub I again? The units of product produced at that practical capacity. So let's go through an example. Here we have Jackson Company, and they produce cylinders, and they currently use an ABC system, and here's the data that we know. Okay, they have setups, welding, machine inspecting, those are all the activities. They make 2 products, or at least for purposes of this illustration, we're going to assume there's only 2 made, and we see the total time spent. Now, activities with consumption ratios and cost are provided in B. So now we see some information here. Okay, so what we see is the percentage of the total broken out. 250 to 750 is 1 to 4, so there's our ratio, 25% and 75%. 1600 to 2400, those percentages are 40% and 60% and so forth. And then we see the total activity cost that our accounting system has given us for the various activities. All right, we sum across, we get the total cost assigned. Okay? Okay, and then when we look at C, we see the products with their cycle time and practical capacity are given. So cylinder A takes 0.4 hours, cylinder B 1.25 hours, and the various practical capacity is given as well. Okay, so now let's go through the example. Using cycle time and practical capacity for each product, calculate the total time for all primary activities. Okay? Now, here's the answer. Let me slide down so you can see that. Okay, so cylinder 1, we're going to take T1, 0.4 times 12,500, and we come up with 5,000 hours. Cylinder 2, take T2, 1.25 times 4,000 equals 5,000 hours. So we add them together, we have 10,000 hours in total. Remember that T represents the total hours. Now, that's where the 0.4 and the 1.25 came from, okay? And you see the 0.4 and the 1.25 there. The 12,500 and the 4,000 came from there. Okay, next we're going to calculate the overhead rate that DBC uses to assign costs. So we're relying on equation 3. Here's what the answer shows us. So using equation 3, we take the 36,000, the total overhead cost, and divide it by the T that we just calculated, right? The 10,000 hours. And we come up with an overhead rate of 360 per labor hour. Now, let's look at question 3. Use the overhead rate calculated in requirement 2 to calculate the overhead cost for each unit. All right, so now we have to go back to the 0.4 and the 1.25 that we already discussed, and we multiply it times 360, and that's how you can come up with the overhead cost per unit. Let me slide on down here. So the total overhead cost assigned to each product would be $1.44, the overhead cost per unit, times the 12,500 units, or the 4,000 units. And remember, those number of units it came from the information on practical capacity. Okay, so next let's look at question 4. What if the units actually produced were 10,000 for cylinder 1 and 4,000 for cylinder 2? If we use DBC, what would be the cost of the unused capacity? Let me slide up and get that answer on the screen. Okay, so the cost of unused capacity would be equal to the overhead rate, that's the $1.44 we calculated, times P sub I, right? Number of units there that we need to put together, 12,500, minus 10,000. This is for cylinder 1. And when we do the multiplication, the cost of the unused capacity is $3,600.